Properties of alkali metals. Chemical properties of alkali metals. The main important chemical properties of alkali metals are given below. First is oxidation state. Oxidation state. Oxidation state. Okay. Alkali metals show fixed oxidation state of +1. The +1 state arises due to loss of minus NH1 elements. Okay. Alkali metals show fixed oxidation state of +1. The +1 state arises due to loss of NH1 electrons. Outer electronic configuration of M negative is NH2 NP6, 1s2 in case of lithium positive, and IP11 ionization potential 11 is very high, and consequently alkali metals do not show +2 oxidation state. This is why alkali metals are monovalent. Alkali metals are monovalent. Okay. Alkali metals show so fixed oxidation state +1 +1. The +1 state arises due to loss of NH1 electrons. Okay. NH1 electron. That means this is metal and this is metals. Arrow mark up M positive and +1 electron arises. 1 electron release and M positive arises. Okay. Outer electronic configuration of M positive is NH2NP6. So 1s2 in case of lithium positive ions, and so ionization potential is very high, and consequently alkali metals do not show +2 oxidation state. This is why alkali metals are monovalent. Alkali metals are monovalent. Okay. Second point, reactivity. Okay. What is reactivity of alkali metals? Reactivity. All alkali metals are high reactive and form electroviolet compounds with almost all nonmetals. All alkali metals are highly reactive. All alkali metals are highly reactive. All alkali metals are highly reactive and form electrovalent compounds. Okay. All alkali metals are highly reactive. And form electrovalent compound with almost all nonmetals. With almost all non-metals, all non-metals. Okay. The reactivity of these elements depend upon their highly electropositive characters. Okay, all alkali metals are highly reactive and form electrovalent compounds with almost all non-metals. Okay, the reactivity of these elements depend upon their highly electropositive character. The reactivity of these elements depends upon their highly electropositive character. Highly electropositive character. Highly electropositive characters. Okay. As we know that the value of ionization potential decreases from lithium to cesium. The value of ionization potential decreases. The value of ionization potential decreases from lithium to cesium. Hence, reactivity increases from lithium to cesium. Hence, reactivity increases from lithium to cesium. Hence, reactivity increases from lithium to cesium. The order of reactivity of these elements is given as cesium. The reactivity of cesium is greater than rubidium, is greater than potassium, is greater than sodium, is greater than lithium. Okay. First point, oxidation state. The alkali metals show fixed oxidation state +1 state arises due to loss of NH1 electrons. Okay, M positions +1 electron releases. Okay, and outer electronic configuration of M positive is NH2 NP6 1s2 in case of lithium positive ions, and so ionization potential is very high, and consequently alkali metals do not show +2 oxidation state. This is why alkali metals are monovalent. Okay. Reactivity. What is reactivity of alkali metals? All alkali metals are highly reactive and form electrovalent compound with almost of non-metals. Okay. All alkali metals are highly reactive and form electrovalent compound with almost all non-metals. All alkali metals are highly reactive and form electrovalent compound with almost all non-metals. The reactivity of these elements depends upon their highly electropositive characters. As we know that the value of ionization potential decreases from lithium to cesium, as reactivity increases from lithium to cesium. The order of reactivity of these elements is given as the reactivity of cesium is very high as compared to reactivity of lithium. Okay. Next, action of air and moisture. Action of air and moisture. Action of air and moisture. Okay. Alkali metals have finite alkali metals have affinity for oxygen. Hence, when exposed to air, they get converted into oxides, hydrides, and finally to carbonates. Okay? Alkali, alkali metals have alkali metals have affinity. Alkali metals have affinity for oxygen, for oxygen, for oxygen. Hence, when exposed to air, hence, when exposed to air, they get converted into oxides. They get converted into oxides, hydrides, and finally to carbonates. Oxides, hydrides, oxide, hydroxide, oxide, hydroxides, and finally to carbonates, and finally to finally to carbonates. Okay, 4M plus O2. Okay, after reaction it is converted into 2M2O, and again M2O is reacted with water, that is also converted into MOH. That means metal hydroxide. This is metal oxide, this is metal hydroxide. So, okay, this is metal hydroxides. And again, MOH is reacted with carbon dioxide and converted metal carbonates. Okay, again MOH, that means metal hydroxide, is reacted with carbon dioxide, and after reaction it is converted metal carbonate M2O3, and plus water is released. Okay, water is released, and where water is, that means the means of water is moisture, and where metals means lithium, sodium, potassium, rubidium, and cesium. Okay, due to reaction with air and moisture, these metals are stored in kerosene ions. When exposed to air, the metal surface becomes dull and tarnished. Due to reaction with air and moisture, due to reaction with air and moisture, these metals are stored in these metals are stored in kerosene oil, stored in kerosene oil, when exposed to air, the metal surface becomes dull. The metal surface becomes dull. dull and tarnished tarnished. Okay. Next, reaction with water. Reaction with water. Alkali metals react with water at ordinary temperatures. Reaction with water. Alkali metals. Alkali metals. Alkali metals react with water. React with water. React with water at ordinary temperature. Ordinary temperature except lithium. Except lithium forming hydroxides. Forming hydroxides. Forming hydroxides and hydrogen gas is produced. Hydrogen gas is produced. Okay. And then 2Na plus 2H2O. Arrow mark of 2NaOH plus hydrogen gas is released. And 2M plus 2H2O. Arrow mark of 2MOH plus H2. Okay. Where M is alkali metals. M is alkali metals. Alkali metals. All or above hydrogen in the electrochemical series. The reactivity order with hydrogen is lithium. Order with hydrogen is lithium is less than sodium is greater than potassium, rubidium and cesium. Reaction of sodium is so violent that it catches fire in water. The hydrogen burns due to heat produced. Next, reaction with hydrogen. 5 point. Reaction with hydrogen. Alkali metals react with hydrogen and form hydride LiH, NaH, KH, etc. Okay. Alkali metals react with hydrogen. Alkali metals react with hydrogen. Alkali metals react with hydrogen and form hydride. And form hydride. Okay. MS 2Na plus H2 arrow mark of 2NaH. Okay. That means 2 metals plus H2 arrow mark of 2MH. 2MH. Okay. The act as a strong reducing agent and are not stable and produce H2 gas by dissolving in waters. Okay. The act as strong. Reducing agent. Strong reducing agents. Okay. The react as strong reducing agent and are not stable Okay, they act as a strong reducing agent and are not stable and produce hydrogen and produce hydrogen gas by dissolving hydrogen gas by dissolving by dissolving in water, okay. MH plus H2O, that is MOH plus H2 gas, okay. A reaction with dill acids. One minute. Reaction with dilute acids, okay. A reaction with dilute acid, okay. Alkali metals react with dilute. Alkali metals react with dilute acids to form salts and produce hydrogen gas. Salt and produce hydrogen gas, okay. 2M plus 2HCl, arrow mark of 2MCl plus hydrogen gas, okay. Alkali metals react with dill acid to form salts and produce hydrogen gas, okay. 2M plus hydrochloric acid, 2MCl plus H2 hydrogen gas, okay. Next is halide, okay. Next is halide, okay. The react with halogens, forming halides. Halides are crystalline solids soluble in water. Lithium chloride, sodium chloride, potassium chloride, etc. Okay. Okay, halides. They react with halogens. Alkali metals react with halogens. They react with halogens. They react with halogens, forming halides. Halides are crystalline. Halides are crystalline. Halides are crystalline solids. Halides are crystalline solids soluble in water. Example: lithium chloride, sodium chloride, potassium chloride, etc. Okay. Okay. 2Li plus Cl2, 2LiCl, 2Na plus chlorine gas. After reaction, 2NaCl, 2K, that is potassium, 2 atoms plus bromine, Br2, arrow mark of 2K, potassium bromide, plus 2M plus H2, that is 2MX, where X is halides and M is metals, okay. X is alkali, X is halogens, that means chlorine, bromine, iodine and fluorine, okay. And M is alkali metals, okay. Alkali metals, M is alkali metals, okay. Next is reaction with oxygen, 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 okay, reaction with oxygen, reaction with oxygen. Alkali metals when heated with oxygen form different types of oxides which depends upon the nature of metals. Okay? Alkali metals, alkali metals, alkali metals when heated with oxygen, when heated with oxygen, form different types of oxides, form different types of oxides which depend upon the nature of the metal, upon the nature of the metal, okay. 4Li plus O2, 2Li2O, okay, lithium monoxide. This is lithium monoxide, okay, and 2 sodium plus O2, that is Na2O2, that is sodium peroxide, that is sodium peroxide, okay, and potassium plus O2, that is potassium superoxide, this is potassium superoxide, potassium superoxide, okay. Metal plus oxygen, that is MO2, where M is potassium, rubidium and cesium, okay. Hence the reactivity of alkali metals with oxygen, increases on moving down the group. It may be noted that under similar conditions with oxygen, lithium monoxides, sodium peroxide, potassium superoxide. This is due to limitation in size, radius of M positive and radius of lithium positive is small. It forms lithium oxygen negative, lithium positive, sodium forms sodium positive, oxygen negative, and oxygen negative, sodium positive, and potassium forms potassium positive, oxygen double negative. That means oxygen double negative ions in superoxide ion. Okay, this is a superoxide ion. Potassium positive, O2 negative, that is or double oxygen negative is a superoxide ion. Superoxide ions. Okay. Next 9 point. Nature of oxide and hydroxides. Nature of oxides and hydroxides. Nature of oxide and hydroxides. Alkali metal oxides and hydroxide all are basic. They do not show amphoteric character. Okay? Amphoteric characters. Okay? Alkali metals oxides and hydroxides. Alkali metals oxides oxide and hydroxide. Alkali metals oxides and hydroxides are all basic. Are all basic. All basic. They do not show. They do not show. They do not show amphoteric character. Amphoteric character. Okay, that is M2O plus 2HCl. Reaction 2NCl plus water. Okay, and after MOH metal hydroxides plus hydrochloric acid is that metal chloride plus water, and as example sodium plus hydrogen chloride after reaction sodium chloride plus half hydrogen atoms. Okay, and Na2, that means Na2 sodium oxide, that is sodium oxide plus hydrochloric acid, that is 2 sodium chloride plus water and sodium hydroxide plus hydrochloric acid after reaction NaCl after reaction NaCl sodium chloride plus water. The metallic character increases from lithium to cesium, and so basic character of metals, metal hydroxide increases from lithium to cesium. Okay, the metallic character increases from lithium to cesium, and show basic character of metals, oxides and methyl hydroxide increases. Show basic character increases. Oxides are hydroxides. Oxides are hydroxides. Okay, from lithium to cesium. Okay, so basic character is increases from lithium, sodium, potassium, rubidium and cesium. Okay, increases. And basic character from lithium oxide, sodium oxide and potassium oxide, rubidium oxide and cesium oxide is increases. Okay, and basic character of hydroxides and basic characters of increases basic character increases from lithium hydroxide, sodium hydroxides, potassium hydroxides, rubidium hydroxides and cesium hydroxides. Okay, in Metal hydroxide radius of M positive increases from lithium to cesium, and hence attraction between metals positive ions and hydroxide decreases from lithium to cesium. Consequently, dissociation of metal hydroxide to metal positive and hydroxide negative increases, and basic strength increases. As a matter of fact, metal hydroxide is strong bases and are 100% ionized. Okay? That means in a metal or hydroxide, okay? In metal hydroxides, radius radius of M positive ion increases. M positive ion increases from lithium to cesium. Lithium positive ions to cesium positive ions. Okay? That means hence attraction between M positive ions and hydroxide ions. That means attraction between M positive and hydroxide ions decreases from lithium positive ions to cesium positive ions. Consequently, dissociation of metal hydroxides M positive ions plus O negative ions increases and basic strength increases. As a matter of fact, metal hydroxide are strong bases. As a fact, metal hydroxides are strong bases and are 100% ionized. Metal hydroxides are M positive ion, okay, plus OH negative ion 100%. In case of metal oxide, metallic character of M increases from lithium to cesium, and so basic character of metal oxide increases from lithium to cesium. Okay. Next, 10 point. Number 10 is carbonates and bicarbonates. Carbonates and bicarbonates okay, carbonates and bicarbonates. Okay. In next heading we will be studying, next lecture we will be studying about carbonate and bicarbonates. Okay. Carbonates and bicarbonates. Okay. Carbonates, properties of alkali metals, chemical properties. Carbonates and bicarbonates. Carbonates of alkali metals increases in thermal stability with increase in atomic number. Lithium carbonate Li2CO3 is least stable, while cesium carbonate CS2CO3 is the most stable to the action of heat. Okay. Thermal stability increases from lithium to cesium. Alkali metals form solid bicarbonates. No other metal forms solid bicarbonates. In qualitative analysis, lithium is exceptional, so it does not form a solid bicarbonate. Thus, lithium bicarbonate exists in solution. All the carbonates and bicarbonates are soluble in water. Okay. Carbonates of alkali metals increases in thermal stability. increases in thermal stability with increase in atomic numbers. Carbonates of alkali metals increases in thermal stability. Okay, carbonates of alkali metals increases in thermal stability with increasing atomic number. Example: lithium carbonate is least stable while cesium carbonate is most stable. To the action of heat, thermal stability increases from lithium to cesium. Alkali metals form solid bicarbonates. No other metals form solid bicarbonates. Bicarbonates evolve carbon dioxide and turn into carbonate on gentle warming. This is one test for bicarbonate in qualitative analysis. Lithium is exceptional, so it does not form a solid bicarbonate. Thus, lithium bicarbonate exists in solution. All the carbonates and bicarbonates are soluble in water. Okay. As an example, sodium carbonate plus water. Okay. 2 sodium hydroxide plus H2CO3 weak acid. This is strong base, and this is weak acid. Okay, weak acid. And again, sodium bicarbonate, 2NaHCO, 3 sodium bicarbonate plus 2H2O water is converted in, after reaction it converted into NaOH, sodium hydroxide, and plus 2H2CO3. Okay. Upon heating, bicarbonates convert into carbonates. Okay. Upon heating bicarbonates convert into carbonates. Okay. As an example, 2 lithium bicarbonate LiSCO3. After heating, lithium carbonate plus water plus carbon dioxide. Okay. Upon heating, bicarbonates convert into carbonates. Okay. Next, 2 sodium bicarbonate. After heating, sodium carbonate plus water plus carbon dioxide gas. And potassium bicarbonate, 2KHCO3. After heating, K2CO3, potassium carbonate plus water plus carbon dioxide gas. Okay. Next, reducing properties. Okay. Reducing properties. Next is reducing properties. Okay. Alkali metals are all strong reducing agent. Alkali metals are all strong reducing agent. Okay. All strong reducing agent. Okay. 1 minute. Alkali metals are all strong reducing agents. This is due to low ionization potential. Ionization ionization potential, ionization potential, okay, and low sublimation energy, and low sublimation energy, sublimation energy, okay, delta Hy, okay. So M solid is M gas and delta Hs, and Mg, that is M gas, M positive gas plus electron ionization potential, and M plus in gaseous state is converted is M plus Aq plus delta Hy, that is M as solid state is converted M plus equal plus E delta H sol, okay, solid, okay. Delta Hs sublimation energy, delta Hs sublimation energy, this is sublimation energy, sublimation energy, this is sublimation energy, okay. Decreases from lithium to cesium. Sublimation energy decreases from lithium to cesium, ionization potential decreases from lithium to cesium, ionization potential decreases from lithium to cesium, and hydration energy delta Hy, hydration energy delta Hy decreases from lithium positive ion to cesium positive ions, okay. The net resultant of delta H solution is the net resultant of delta H solution is lithium is less than sodium is greater than potassium, rubidium and cesium, okay. Lower the value of delta H solution, greater is tendency of reaction to occur, hence oxidation potential for lithium is greatest and reducing power of lithium is greatest, okay. Lower the value of delta H hydration solution, lower the value of delta H solution, greater is the tendency of the reaction to occur, hence oxidation potential for lithium is greatest and reducing power of lithium is greatest, okay. Energy for M solid is M positive plus electron, that is lithium, sodium, potassium, rubidium and cesium. 3.05 electron volt, 7.21 electron volt, 2.93 electron volt, 2.93 and 2.92 volts. Okay, thus reducing power as strength. Thus reducing power has the strength. Reducing power has the strength. If lithium is greater than sodium, is less than potassium, rubidium and cesium. Okay, it may be noted that through ionization of lithium, tendency of lithium to lose electron in gaseous state. It may be noted that though ionization potential of lithium, tendency of lithium to lose electron in gaseous state is highest. Its reducing power tendency of lithium to lose electron to form aqueous lithium positive ion is higher than sodium. This is due to high hydration energy of lithium positive, which compensates for high ionization potential. Therefore, lithium is the strongest reducing agent because of its greater hydration energy. Reducing power property has been shown by the reaction given below. You can show ammonium chloride, that is ammonium chloride, AlCl3, ammonium chloride plus potassium is converted in ammonium plus potassium chloride. Okay, next is sulfate. Okay, sulfate. Next is sulfate. Okay, sulfate. Alkali metals form sulfates by reaction with hydrogen sulfide H2SO4. Lithium forms monohydrate sulfate, lithium sulfate and water, while other form alum lye. Okay, so alkali metals form sulfates by reaction with H2SO4. Okay, sulfates. Alkali metals form sulfates by reaction. Alkali metals form sulfates. Alkali metals form sulfates by reaction with H2SO4, hydrogen sulfate. Lithium forms monohydrate sulfates. Lithium forms monohydrate sulfate Li2SO4, that is H2O. Okay, while other form alum like. Okay, then Na2SO4 Al2SO4 whole thrice 24H2O. यह फार्मूला फिटकरी का, किसका है? फिटकरी का. ओके, एलम Na2H4 Al2SO4 all thrice 24H2O. ओके, फिटकरी में सोडियम होता है, सल्फर होता है, ऑक्सीजन होता है, अमोनियम होता है और पानी के 24 कण होते हैं. ओके, then the Na2SO4 Al2SO4 all thrice and 24H2O. This is the formula of a fitkari, that means alum, potash alum, sodium alum. Okay, sorry, this is the sodium alum. It is not the formula of a fitkari, or that means alums. Okay, and the formula of potash alum is this is a fitkari formula K2SO4 Al2SO4 whole thrice and 24H2O. This is potash alum. Potash alum. Potash alum. Okay. Lithium sulfate does not form alums. Lithium sulfate does not form alum. Does not form alums. Okay. 13 point nitrates. All nitrates of alkali metals are soluble in water. All nitrates of alkali metals are soluble in water. Alkali metals nitrates are decomposed on heating, giving nitrates and oxygen. Okay. Sodium nitrate NaNO3. Sodium nitrate, and after heating this is converted to NaNO2 plus O2. Okay, and this is nitrates and this is nitrites. This is nitrite, sodium nitrites. This is sodium nitrates. Okay. So all nitrates of alkali metals are soluble in water. Alkali metals nitrates are decomposed on heating, giving nitrites and oxygen. This is sodium nitrates, and after heating this is decomposed in nitrites and oxygen. Okay. Then potassium nitrates 2KNO3. Potassium nitrates. This is potassium nitrate. Potassium nitrate is after heating it is decomposed in potassium nitrites 2KNO2 plus O2. Potassium nitrites. Okay. Nitrates are used as oxidizing agents. Okay, oxidizing agents. Nitrates are used as oxidizing agents. Okay, oxidizing agent. Lithium nitrate decomposed in different manner, producing lithium oxide, nitrogen dioxide and oxygen. Okay, 4LiNO3. Okay, lithium nitrate is decomposed into lithium oxide Li2O plus nitrites 4NO2 plus O2. Okay, this is nitrogen dioxide and this is oxygen. Okay, nitrates are used as oxidizing agent. Lithium nitrates decomposed in different manner, producing lithium oxide and nitrogen dioxide and oxygen. Okay, next is organometallic. Compounds. Next is organometallic compounds. Okay, organometallic compounds. Okay. Organometallic compounds. Organometallic compounds. Okay. The alkali metal replace hydrogen in organic acids, forming salts such as CH3COO and sodium acetate, and C6H5COO potassium benzoate. Potassium benzoate. Okay. Okay. That alkali metals replace hydrogen in organic acid, that is forming salt such as CH3COONA. This is sodium acetate. Sodium acetate. This is sodium acetate, and C6H5COOK potassium benzoate. This is potassium benzoate. Okay. And lithium forms a number of covalent alkalis and aryls, which are of great importance in the preparation of organometallic compounds. Lithium and sodium combine with organic compounds and form organometallic compounds. Okay. Lithium and sodium combine with organic compounds and form organometallic compounds. Okay. Now RCl plus 2Li, that is LiR plus LiCl. Okay. That is C6H5Br. Okay. That is 2Li is converted C6H5Li plus LiBr, lithium bromide. This is phenyl lithium. This is phenyl lithium. This is phenyl lithium. Okay. This is phenyl lithium, and 3C5H6 plus 2Na, that is 2C5H5Na plus C5H8. Okay. Organolithium compounds are of great importance in organic synthesis. Okay. Organolithium compounds are of great importance in organic synthesis. Okay. Next is a complex salt. Okay. Complexes of alkali metals. Complex salts. That means complexes of alkali metals. Complex salts. That means complexes of alkali metals. Alkali metals have a weak tendency to form complexes. This is because the factors favoring complex formation are small size, high charge, and impurity orbitals of low energy. For forming the bonds, alkali metals ion possesses large size and have a low charge, but ionic size of lithium is small. Therefore, it forms some complexes such as lithium chelating agent. Complexes of lithium and sodium are given below. Okay. Salicylaldehyde. This is salicylaldehyde. Okay. Salicylaldehyde. This is salicylaldehyde formula. CH. This is salicylaldehyde. and plus sodium positive ions is also converted in as like this. This is oxygen and CHO aldehyde group, and this is sodium. Okay, sodium and this is OH2 and OH2 is converted into as like this. Okay, that is C, and double bond with oxygen, and that is sodium. Okay, and that is oxygen, double bond carbon, hydrogen. This is oxygen. Okay, and this is converted into like this. Okay, and this is single bond with carbon, hydrogen. Okay, and acetone, that means K2 form. CH3 C double bond O, that is acetone. This is acetone. This is acetone, that means keto form. This is keto form. Okay, is CH3 carbon double bond oxygen. This is anal form. This is anal form plus lithium positive ions. That is CH3 carbon CH3 carbon double bond oxygen, single bond oxygen, that is Li lithium plus hydrogen positive ions is converted in CH3 carbon oxygen, carbon double bond oxygen, that is lithium oxygen, lithium, that is lithium, and that is lithium oxygen double bond carbon oxygen, double bond carbon oxygen, single bond carbon, and This is a CH3 with a single bond, and with a double bond CH, and with a single bond carbon, and carbon is also converted in single bond CH3. Okay, CH3. Okay. Analytical test. Alkali metal salts give characteristics flame, and for example, sodium salts gives a golden yellow, and potassium salt gives a violet flame in Bunsen flame. The characteristics color is due to emission of energy. When sodium chloride, for example, is heated in region, sodium gas and chlorine gas are further heating balance. Electrons of sodium go to higher orbitals. When electron drops from higher orbitals to lower orbitals, energy is released, which appears as golden yellow. Okay. Next, anomalous behavior of lithium.